Let's look at problem 1440 in your book. Mountain highways with long descents have an escape roads with a steep incline for vehicles to take if their brakes have failed. If one of these roads is inclined at 40 degrees above horizontal, how long must it be to stop a 10-ton truck traveling at 80 miles per hour? Okay. So this is what's given. So the weight is 10 ton, so that's 10 times 2,000 pounds, so that's equal to 20,000 pounds. Okay. Velocity is 80 miles per hour, so times let's convert it to feet per second. So a mile has 50 to 80 feet in it. So when you do all of that, you get 117.3 feet per second. Okay. Right. Now, so what happens is you need to, so this, a truck, so if a truck is, if a truck is, if a truck has lost its brakes, it just needs to, take this ramp, right, with the initial velocity of 80 miles per hour. So how long should this be? How long should that be? And that angle is given as 40 degrees. How long should it be so that this truck traveling at 80 miles per hour can stop? Okay, so it's a simple formula. So we equate the kinetic energy to the potential energy. From that we get the height h, and then with the 40 degrees in height we can figure out the d. Okay? So half mv squared is equal to mgh. Now in this particular problem though, what happens is we really don't need to worry about the mass, because m and m get cancelled. In cases where there's friction and all, then you have the reaction, and that depends on the friction depends on the reaction, and that depends on the weight of the body. So that needs to be considered. But in this case, really you can just cancel it out right here, and that'll ease your calculation. Half v square, so we got 117.3 squared is g 32.2 h, right? So h is, once you do all of this, you get 213.7 feet. So that is the height, that's the h. Now to find the d, what do you need to do? So sine 40 degrees is equal to h over d. H we know is 213.7 over d, and from sine 40 to 13.7 we can calculate d, which comes to 332.5 feet. So that's the d. Here, I'm sorry I kind of drew a little curve here, but it's we're assuming it's a straight line. Okay. All right.